Example 1, testing a hypothesis about a population standard deviation with a left tail test. Now we're going to use the p-value approach in this example. So in example 2 from section 10.3, the quality control engineer for M&M Mars tested whether the mean weight of fun-sized Snickers was 20.1 grams. Suppose that the standard deviation of the weight of the candy was 0.75 gram before a machine recalibration. The engineer wants to know if the recalibration resulted in more consistent weights. We want to conduct the appropriate test at the alpha equals 0.05 level of significance, and the data are reproduced in table 2 over here on the left. Now the approach, if the recalibration results in more consistent weights, then the standard deviation weight should be less than it was prior to recalibration. We want to test if the population standard deviation is less than 0.75 gram. Before we can perform the hypothesis test, we want to verify that the data come from a population that is normally distributed by constructing a normal probability plot. Then follow steps 1 through 5. Now, if we want to determine that it is a normally distributed population, we can come up over here, select graph, go down to QQ plot. We have our data already listed in here in StatCrunch. Select the column and then compute, and then we get a line that would resemble an approximately normal distribution. Now, in step 1, we need this evidence to conclude that the population standard deviation is less than 0.75 gram. This can be written as population standard deviation is less than 0.75. So the null hypothesis is always going to have the equality. So the population standard deviation is going to equal 0.75 gram versus the alternative hypothesis where population standard deviation is less than 0.75 gram. And this is a left tail test. Now the level of significance is alpha, which is equal to 0.05, and we're using the p-value approach. Now we want to be able to find the standard deviation of the data in the table, and by doing so we can go back to StatCrunch. We have our data, we can manually put it in, go to Stat, Summary Stat, and then select Columns, and then make sure we put in the column over here, find the standard deviation, and then we can get our standard deviation from the data in that table. So you can see here there is the standard deviation. Now, then we need to find the test statistic. So the test statistic formula is taking n-1, which is 11 minus 1, times the sample standard deviation, 0.6404 squared, over the population standard deviation from our hypothesis 0.75 squared, which gives us a test statistic of 7.291. And now because this is a left tail test, the p-value is the area under the chi-square distribution with 11 minus 1 equals 10 degrees of freedom to the left of the test statistic, which is 7.291, as you can see here in figure 22. Now what we want to be able to do is locate the p-value here with 10 degrees of freedom. Now if we're looking at this table here, okay, we want to find the row that corresponds to 10. Now if you look at the value of 7.291, okay, it's going to be greater even at 0.90 when the area under the chi distribution has 0.10, because if this is 0.10, then therefore this is 0.90. So that means this is the area to the right, which is 4.865. So the p-value is greater than 0.10. Now, if we wanted to use technology, okay, in StatCrunch, what we want to do is, in order to find the p-value, we're going to follow the following information. It says if you have raw data, enter them into the spreadsheet, which is what we've done. Okay, so let's take a look at that. Here is the raw data. And then we're going to select Stat, highlight Variance Stats, highlight one sample, and since we have data, we're going to select with data. So let's go ahead and do that. We're going to go to Stat, and then with Data. Okay, and now it says, if you choose with Data, select the column that has the observations. And then you're going to choose the Hypothesis Test Radio button, enter the value of the variance stated in the null hypothesis, and then choose the direction of the alternative hypothesis from the pull-down menu, and then click Compute. So here we have our information. So let's take a look at that. So up here we have 0.75. Let's go back up here. We're going to select Snickers. Okay, and then we have the hypothesis test, which is what we want. And so we know that we got to put in the variance. So since we have 0.75 as our standard deviation, then what would that look like if it was the variance? That means we'd have to square the 0.75. So recall that 0.75 squared is 0.5625. So we're going to put in here 0.5625, and then we're going to have the less than, because that's what it says in our alternative hypothesis. And then what we're going to do is select Compute. And then therefore, you can see that this is our data that we get. We get a sample variance of 0.4100, degrees of freedom of 10. We get our chi-square, which is 7.29. And then we have the p-value, which is 0.3022, and that's what we wanted. So again, keep in mind that when we're putting this information into StatCrunch, we have to put it in as a variance, which means we have to square what our standard deviation was. If you look down here, there is our p-value, which is 0.3022. And therefore, the p-value is greater than the level of significance, 0.3022, and therefore we do not reject the null hypothesis. And so in step 5, there is not sufficient evidence at the alpha equals 0.05 level of significance to conclude the standard deviation of the weight of fun-sized Snickers is less than 0.75 gram. It appears that the recalibration did not result in more consistent weights.